Welcome to Hey Gen Podcast. Today we're diving into Roger Penrose's fascinating ideas about the universe acting as a cosmic clock, mass, frequency, and even the cyclic nature of the cosmos. Let's get started.
That sounds incredible. So what's the main idea behind Penrose's perspective?
Well, Penrose suggests that mass is intrinsically linked to frequency, meaning that massive particles actually tick like tiny clocks.
Wait, particles ticking like clocks? How does that work?
Yeah, so according to Planck's equation, E equals h times F, so energy is proportional to frequency. If you have mass, you have energy,
Right.
and therefore an inherent frequency. It's like every particle with mass has its own beat, its own rhythm.
So without mass, there's no ticking, no clock?
Exactly. Without mass, you lose this ticking mechanism, and without that, you can't measure time or space. There's no
Wow.
scale.
That's mind-blowing. It's like mass gives structure to the universe.
Right. And Penrose takes it further by proposing a cyclic universe where the
Oh,
Big Bang isn't a one-time event but part of endless cycles of cosmic expansion and contraction.
so our universe could be just one of many cycles?
Exactly. And what's really intriguing, it's just so exciting, is that we might detect remnants of previous cycles. For instance, gravitational waves from supermassive black hole collisions in prior universes could be present in our current cosmic microwave background.
Wow, so we're potentially seeing echoes from before our own Big Bang?
Yeah, it's incredible, right? It
Yeah.
connects us to a much larger cosmic history.
But wouldn't detecting those signals be incredibly difficult?
Definitely challenging, but with advancements in technology, like more sensitive gravitational wave detectors,
Right.
it's possible we could find evidence supporting this theory.
That's astounding. How does this tie into the Fermi paradox?
Great question. Penrose suggests that advanced civilizations might communicate across cosmic epochs, using methods beyond our comprehension, perhaps even manipulating space-time itself.
So maybe we're not picking up extraterrestrial signals because we're not looking in the right way?
Exactly. It's like we're tuning into the wrong frequency. If they're using advanced physics to communicate, we might be missing
Yeah.
it entirely.
That's a bit humbling, isn't it?
Totally. It challenges us to think bigger,
Yeah.
to broaden our horizons when searching for extraterrestrial intelligence.
But couldn't it also mean that there are no other civilizations out there?
It's possible, but Penrose's idea suggests that maybe they're out there but communicating in ways we haven't yet understood.
I see, but if we can't detect them, does it really matter?
Well, it's important because it pushes us to develop new technologies and theories. It's like, when we first discovered radio waves,
Right.
we had no idea how transformative they'd become.
That's a fair point.
Speaking of transformative, Penrose also talks about the importance of complex numbers in physics.
Oh, the imaginary numbers, right?
Yes. Introducing I, the square root of -1, it seems abstract, but it's revolutionized math and physics. It's
Right.
crucial in quantum mechanics, for instance.
It's amazing how something so abstract can have real-world applications.
Absolutely. It's like sometimes the most out there ideas lead to the
Yeah.
biggest breakthroughs.
It's like math is the universe's own code language.
Exactly. And Penrose believes that to grasp deeper truths, we need to think beyond conventional methods.
Which brings us to consciousness, right?
Yes, he delves into the mystery of consciousness,
Right.
suggesting it may be linked to quantum processes.
That's fascinating, but also controversial, isn't it?
It is, but he argues that consciousness might not be fully explained by classical computation alone.
So he thinks the mind could be connected to the quantum realm?
Exactly. And that could explain phenomena that are currently beyond our understanding.
Yeah.
It's like we're just scratching the surface.
It's a lot to wrap your head around. But isn't there skepticism about linking quantum mechanics to consciousness?
Absolutely, there's debate. But exploring these ideas pushes the boundaries of science and philosophy.
Right.
We might find answers, or at least better questions.
I love how Penrose's work unites physics, math, and even consciousness.
Me too, it shows
Yeah.
how interconnected everything is.
So what's the big takeaway from all this?
Well, Penrose encourages us to question our assumptions, to look for deeper connections in the universe. Whether it's mass acting as a cosmic clock or civilizations communicating across cosmic cycles, there's so much more to discover.
That's truly inspiring. It reminds us that the universe is full of mysteries waiting to be unraveled.
Exactly. And it's up to us to keep exploring, keep asking questions, and keep pushing the boundaries of knowledge. So, have you ever thought about how mass is kind of like a cosmic clock?
Wait, a clock?
Yeah, exactly. Roger Penrose talks about this idea where every particle with mass ticks in its own way based on its
Mm-hmm.
intrinsic frequency.
That's fascinating. So you're saying mass and time are directly connected?
Absolutely. It's all tied back to Planck's equation, E equals hf, where energy and frequency are linked. So mass gives us these tiny, precise clocks ticking away in the universe,
Right.
and without mass, there's no way to measure time or space.
Wow, so in a universe without mass, time just doesn't exist?
Pretty much. It's like without mass, we lose the scales we use to define space and time. Everything
Yeah,
becomes kind of meaningless in terms of measurement.
that's mind-blowing. And does this connect to his idea of the cyclic universe?
Yes, Penrose suggests that the universe goes through cycles like the
Mm-hmm.
Big Bang wasn't just a one-time event, but a recurring one.
So you're saying our universe could be just one of many cycles?
Exactly. And here's the wild part. He thinks we might be able to detect signals from previous cycles like
No
gravitational
way.
waves from ancient black hole collisions.
That's incredible. How would we even detect something like that?
Well, it's challenging, but these gravitational waves could leave imprints in the cosmic microwave background, offering us
Right.
glimpses into events before our own Big Bang.
It's like having a message from a previous universe.
Exactly. And it really changes how we think about the universe's origin and its future,
Yeah.
making it a continuous, eternal process rather than a singular event.
But doesn't this tie into the Fermi paradox somehow?
Yes, it does. Penrose speculates that advanced civilizations might communicate across these cosmic cycles, which could be why we haven't detected them yet.
So they're using methods beyond our comprehension?
Exactly. They might be manipulating space-time in ways we can't even imagine, so our
Right.
search methods might be too primitive.
That's a bit humbling, isn't it?
It really is. It suggests we need to expand our thinking when it comes
Yeah.
to searching for extraterrestrial intelligence.
Speaking of expanding thinking, didn't Penrose also talk about complex numbers and their unexpected utility?
Yes, he highlights how introducing the imaginary unit I seemed abstract at first, but turned out to be crucial in quantum mechanics and engineering.
So, math concepts that seem pointless can actually unlock big secrets?
Exactly. It's like math is this language that can describe reality in ways we don't initially see, and these
Right.
abstract ideas can have profound physical implications.
That's really inspiring. Makes you wonder what other mathematical concepts are waiting to be discovered.
Definitely. And it shows the power of human curiosity and imagination driving us to
Yeah.
explore beyond the obvious.
But, what about his views on consciousness?
Yes. Penrose delves deep into the mystery of consciousness, suggesting it's more than just computational processes and might be tied to quantum mechanics.
So he thinks consciousness is linked to the fundamental fabric of reality?
Exactly. He proposes that our understanding of the universe isn't complete without comprehending consciousness,
Right.
and that it might be intertwined with quantum phenomena.
That's a bold claim. Do you think that's plausible?
Well, it's definitely controversial, but it opens up new avenues for research
Yeah.
and challenges us to think differently about the mind and reality.
It does make you wonder how much we don't know.
Absolutely. It's like we're just scratching the surface of understanding the cosmos and ourselves.
And maybe by exploring these ideas, we can make breakthroughs we can't even imagine yet.
That's the hope. It's the beauty of science and philosophy intertwining, pushing the boundaries
Right.
of knowledge.
Speaking of boundaries, his ideas about the conformal structure and scaling of the universe are pretty mind-bending.
They are. He uses the concept of shapes maintaining their form regardless of scale to explain
Yeah.
how the universe could transition from one cycle to another.
So, like, the universe's shape stays the same even if its size changes?
Exactly. It's like those fractal patterns that look the same no matter how much you zoom in or out, offering a new perspective on space-time.
That's a cool way to visualize it.
It really is. It helps make sense of complex ideas by relating them to visual concepts, making them
Right.
more accessible.
You know, all this talk makes me feel like we're part of something much bigger.
I feel the same way. It's humbling and exciting
Yeah.
to think about our place in the vast cosmos.
And it motivates us to keep exploring and asking questions.
Absolutely. Curiosity is the driving force behind all these discoveries, and who knows what we'll uncover next.
Well, this has been an enlightening conversation.
It really has. Thanks for diving into these ideas with
Yeah.
me. It's been a pleasure exploring Penrose's concepts together.
Definitely. Let's do this again soon.
Welcome to Hey Gen Podcast. Today, we're diving into some mind-bending ideas about the universe, mass, time, and consciousness inspired by Roger Penrose. Let's jump right in.
Absolutely. Can't wait to get into it. So what's the big idea that Penrose is proposing here?
Well, Penrose suggests that every particle of mass in the universe acts like its own tiny clock, ticking away at a frequency intrinsic to its mass. It's like
Mm-hmm.
everything with mass is keeping time in its own way.
Wait, so you're saying mass and time are directly connected?
Exactly. Using Planck's equation, E equals h times frequency, and combining it with Einstein's E equals mc squared, we see that mass and frequency
Right.
are linked. So mass essentially gives us a way to measure time.
That's wild. So without mass, there'd be no time?
Yeah, pretty much. Without mass, there's no clock to tick, no scale to measure time or space.
Oh, wow.
It's like the universe would lose its rhythm entirely.
That's a bit mind-blowing. So how does this tie into his idea of a cyclic universe?
Penrose proposes that the universe isn't a one-off event from the Big Bang, but actually goes through cycles of expansion and contraction. And
Interesting.
get this, he thinks we might detect signals from previous cycles,
Signals like what?
like gravitational waves from supermassive black hole collisions in past universes.
No way.
These waves could traverse through cosmic epochs and be detectable in our current universe.
So we're potentially receiving messages from before our own Big Bang?
Exactly. It's like cosmic archaeology, digging into the universe's history.
That's incredible.
It totally reshapes how we think about time and space.
But hold on, wouldn't these signals be insanely weak by now? How could we possibly detect them?
Well, that's the challenge, isn't it? But with advancements in technology,
True.
who knows? Maybe we'll develop instruments sensitive enough to pick up these ancient whispers of the cosmos.
It's like trying to hear a pin drop in a stadium.
Exactly, but hey, science loves a good challenge. Now, this also
Haha,
ties
absolutely.
into the Fermi paradox.
Remind me, that's the where is everybody question about extraterrestrial life, right?
Yep. Penrose suggests that advanced civilizations might communicate in ways we can't even comprehend yet.
Right.
Maybe they're using methods that manipulate space-time itself.
So while we're listening for radio waves, they're sending quantum postcards?
Haha, exactly. We're like kids with tin cans and string while they're using smartphones.
Yeah.
It really broadens the scope of our search for intelligent life.
It also makes me wonder if we're even capable of understanding such advanced communications yet.
That's a good point. Maybe we need to expand our technologies and theories, and that's where the magic of mathematics comes in.
Ah, yes, Penrose's thoughts on complex numbers, right?
Exactly. Introducing the imaginary unit I opens up a whole new world in mathematics and physics.
Right.
Without it, quantum mechanics wouldn't be the same.
It's funny how something we call imaginary is so essential to real-world physics.
I know, it's ironic.
Yeah.
It shows how abstract concepts can have profound practical applications.
So, in a way, math isn't just a tool. It's like the universe's own language.
Exactly. And speaking of profound concepts, Penrose also dives into the mystery of consciousness. He doesn't think
This is a big one.
is just a byproduct of complex computations.
Right. He suggests it might be linked to quantum processes, doesn't he?
Yes. He believes the true nature of consciousness may be intertwined with the quantum realm.
Interesting.
It hints at a deeper connection between the mind and reality itself.
That's both fascinating and a bit unsettling.
Agreed. It challenges our understanding of what it means to be conscious beings.
Do you think we'll ever fully understand consciousness?
Honestly, I don't know. It's one of the greatest mysteries out there. But that's what makes it so intriguing to explore.
Absolutely. It's like the final frontier, not just outer space, but inner space.
Well put. And who knows? Maybe cracking the consciousness code will unlock new realms of physics and reality. It's exciting
Let's
to
hope
think
so.
about the possibilities.
So, to wrap it all up, Penrose's work really bridges the gap between physics, mathematics, and even philosophy.
Exactly.
Right.
It's a testament to how interconnected everything is, from tiny particles ticking like clocks to the vast cycles of the universe.
And it reminds us that the quest for understanding is never ending.
Absolutely. It's driven by curiosity and wonder, a true reflection of the human spirit.
Couldn't agree more. This conversation has definitely given me a lot to ponder.
Same here.
Yeah.
Thanks for diving into these concepts with me. It's been a blast.
Anytime. Looking forward to our next deep dive into the mysteries of the universe.
Me too. Until next time on Hey Gen Podcast, keep exploring and stay curious. Welcome to our podcast, Today we're diving into the mind-bending ideas of Roger Penrose about the universe. Let's get started.
Oh, I'm super excited about this. So, Penrose has some fascinating thoughts on how mass relates to space-time, right?
Exactly. He suggests that every massive particle is like a tiny clock ticking away with its own intrinsic frequency. It's all based on
Right.
Planck's equation, E equals h nu.
Wait, so you're saying mass and frequency are directly connected?
Yeah, that's right. It's like mass gives rise to this fundamental rhythm in the cosmos.
Mm-hmm.
Without mass, there'd be no clocks, no way to measure time or space.
That's mind-blowing. So massless particles can't keep time?
Exactly. Without mass, particles don't have that intrinsic frequency. It's like the universe loses its scale.
Yeah.
Time and space become meaningless without mass to anchor them.
Wow, that's deep. But how does this tie into his idea of a cyclic universe?
Great question. Penrose proposes that the universe goes through cycles of big bangs and expansions. So
Oh,
our Big
interesting.
Bang might just be one of many.
So it's like the universe is reborn over and over?
Exactly. And he thinks we might detect signals from previous cycles,
Really?
like gravitational waves from massive black hole collisions in past universes.
That's incredible, but do we have any evidence of that?
Well, it's speculative, but it's possible that some of the gravitational waves we detect are ancient, crossing over from previous cycles. It's a
Hmm,
fascinating idea that pushes the boundaries of cosmology.
it definitely does. How does this relate to the Fermi paradox?
So, Penrose suggests that advanced civilizations might communicate across these cosmic cycles.
I see.
Maybe they're using signals we haven't even considered yet.
Like manipulating space-time itself?
Exactly. It's possible they're using methods beyond our current understanding. It could explain
Yeah,
why we haven't detected them. They're operating on a whole different level.
that's a wild thought. So maybe we're not alone. We're just not listening correctly.
Precisely. It's like tuning into the wrong frequency. We might
Right.
need to expand our search methods.
Speaking of frequencies, how about his views on complex numbers in mathematics?
Oh, that's a favorite topic. Penrose emphasizes the importance of complex numbers, especially the imaginary unit
Yeah,
I. Even though it seems abstract, it's essential in quantum mechanics and engineering.
it's amazing how something so imaginary is so vital in real-world applications.
Exactly. It's like math reveals hidden layers of
Mm-hmm.
reality. These concepts, while abstract, help us understand the universe at a fundamental level.
That's truly fascinating. But what about consciousness? Penrose has some intriguing ideas there too, right?
Yes, he does. He questions the idea that consciousness is just computational.
Right.
He thinks it might be tied to quantum processes in the brain.
So, consciousness could be connected to the fabric of reality itself?
Exactly. Penrose suggests that the mind could be tapping into quantum mechanics.
Wow.
It's a hypothesis that could revolutionize our understanding of the mind.
That's both exciting and a bit overwhelming.
Totally. It opens up so many questions about free will, perception, and reality.
Yeah.
It's pushing the boundaries of science and philosophy.
Do you think we'll ever fully understand consciousness?
That's a tough one. It's like the ultimate frontier. But with advances
Mm-hmm.
in quantum biology, who knows? We might get closer.
It's exciting to think about. Penrose's ideas really tie together physics, math, and philosophy.
They do. It's a holistic approach to understanding
Right.
reality. He shows how interconnected everything is, from particles to consciousness.
It reminds me of how the universe is like a giant interconnected web.
Exactly, and we're a part of that web.
Yeah.
Our quest to understand it reflects our place within it.
Speaking of quests, what's next for this field of study?
Well, there's so much to explore. From detecting signals from previous universes to understanding quantum consciousness, the
Right.
possibilities are endless.
It's incredible. Penrose's work really inspires us to think bigger.
Absolutely, it's a call to push beyond our current limits,
Yeah.
to explore the unknown with curiosity and wonder.
Well, this has been an enlightening discussion.
It sure has. Thanks for joining me on this deep dive into Penrose's universe. Until next
My
time.
pleasure.
Welcome to the Hey Gen podcast. Today we're diving into some of Roger Penrose's most mind-bending ideas about the universe.
Oh, this is going to be fascinating. What's the first big idea we're tackling?
Well, Penrose talks about how mass is intrinsically linked to time through frequency. It's like every particle of mass is a tiny clock ticking away at its own frequency.
Wait, so you're saying mass and time are connected through frequency?
Exactly. Using Planck's equation, E equals h times f, where energy is proportional to frequency. So mass through Einstein's E equals mc squared ties back to frequency.
Right. That's wild. So without mass, there wouldn't be any clocks to measure time?
Yeah, precisely. Without mass, there's no way to define time or even space.
Wow.
It's like the fabric of space-time depends on the existence of mass.
That's a pretty profound thought. So how does this relate to his idea of a cyclic universe?
Oh, that's where it gets even more intriguing. Penrose proposes that the universe isn't just a one-time Big Bang event, but goes through infinite cycles. Each cycle starts with a Big Bang and ends in a kind of fade out into the next one.
So you're saying our universe could be just one of many cycles?
Yes, and he suggests that we might detect signals from previous cycles.
Really?
Like gravitational waves from ancient black hole collisions.
That's incredible. Have we found any evidence of these signals?
Well, there are some anomalies in the cosmic microwave background that might be hints.
Interesting.
But it's still a hot topic of debate among scientists.
I bet. It also makes me think about the Fermi paradox.
Absolutely. Penrose offers a unique take on that. He suggests advanced civilizations might communicate across cosmic epochs.
Wait,
they could
what?
be sending messages through space-time itself.
That's mind-blowing, but how would we even begin to detect such signals?
That's the challenge. He implies we're possibly not looking in the right way. Maybe they're using methods beyond our current understanding.
It really expands the whole search for extraterrestrial intelligence, doesn't it?
Exactly. It's like we're tuning into the wrong channels.
Yeah.
We might need to rethink our approach entirely.
That makes sense. So, switching gears, what's his take on mathematics and all this?
Oh, he absolutely loves the elegance of mathematics, especially complex numbers. Introducing the imaginary unit I opens up so many possibilities in physics.
Like in quantum mechanics and electrical engineering?
Exactly. It's amazing how an abstract concept can have such practical applications. It shows how deeply math is woven into the fabric of reality.
It's funny how something called imaginary is so essential to the real world.
Ha, I know, right? It's one of those quirks that makes math so fascinating.
Absolutely.
And speaking of fascinating, Penrose also dives into consciousness.
Yes, I've heard he has some unconventional views on that topic.
Definitely. He challenges the idea that consciousness is just a byproduct of complex computations.
Right.
He thinks it might be linked to quantum mechanics.
So our minds could be connected to the quantum realm?
Exactly. It's like consciousness arises from quantum processes in the brain. It's a controversial idea, but really thought-provoking.
But isn't there a lot of skepticism about that theory?
Oh, absolutely. Many scientists argue that the brain is too warm and noisy for quantum effects. But Penrose believes microtubules in neurons might support quantum coherence.
It's certainly a bold hypothesis. I guess only time and more research will tell.
Exactly. It's like we're on the edge of a new frontier in understanding consciousness.
Yeah.
And that's what's exciting about science, pushing the boundaries of what's known.
Couldn't agree more. So, bringing it back to the universe, what does all this mean for our understanding of reality?
Well, it highlights how interconnected everything is. From particles acting as clocks to the cycles of the universe, there's a profound unity.
It's humbling, isn't it?
Absolutely. It reminds us that we're part of a much larger cosmic story. And our quest to understand it is what drives humanity forward.
Well said. This has been an enlightening conversation.
Definitely. Thanks for exploring these mind-bending concepts with me.
Anytime.
Can't wait for our next deep dive. You know, sometimes I think about how mass and time are connected in ways that just blow my mind.
Like how exactly?
Well, Roger Penrose has this idea that mass is inherently linked to frequency. Like every particle is its own little clock.
Oh, right.
Isn't that wild?
Yeah, so you're saying that particles tick like clocks because of their mass?
Exactly. It's based on Planck's equation, E equals h times nu, where energy is proportional to frequency. So if you think about it, mass and energy are equivalent, thanks to Einstein, and that means mass has an intrinsic frequency.
That's kind of mind-bending. So without mass, there'd be no clocks?
Yeah, that's the idea. Without mass, you don't have the frequencies that define time. It's like, without clocks, we can't measure space and time in the usual way.
So the universe would be sort of scaleless?
Precisely. The whole scale of space and time depends on mass.
Right.
Penrose even talks about conformal structure, where you can look at shapes without considering their size.
That's like those fractals where the pattern repeats no matter how much you zoom in or out?
Exactly, like the eye of a devil, or more mathematically, the conformal infinity. It's the idea that the shape remains constant even if the size changes.
Wow, that's deep. But how does this tie into the universe's beginning?
Well, Penrose proposes a cyclic universe. He suggests that the Big Bang isn't a one-time event, but part of an endless cycle. Each
Interesting.
cycle, he calls them aeons, expands, ages, and then gives birth to the next.
So, kind of like a cosmic phoenix rising from its own ashes?
Haha, yeah, that's a great way to put it. And here's the kicker. Penrose believes we might detect signals from previous cycles.
Wait, signals from before the Big Bang? How would
Yeah,
that even work?
through gravitational waves. Supermassive black holes colliding in previous aeons could emit gravitational waves that somehow make it into our current universe.
That's trippy. But isn't everything wiped out at the Big Bang?
You'd think so, but in the conformal geometry Penrose describes, the infinite future of one aeon becomes the Big Bang of the
I
next.
see.
So information could theoretically pass through.
So maybe those gravitational waves are like messages in a bottle from previous universes?
Exactly. And it even ties into the Fermi paradox.
That's the where is everybody thing about extraterrestrial life, right?
Yep. Penrose suggests that advanced civilizations might have found ways to communicate across cosmic epochs. Maybe
Wow.
they're using methods we can't even comprehend yet.
So instead of sending radio signals, they're encoding messages in gravitational waves?
Or perhaps manipulating space-time itself. It's like, we're tuning into the wrong frequency.
That's a humbling thought. Makes our search for alien life feel a bit naive.
Possibly. It suggests we need to broaden our horizons, you know?
Speaking of broadening horizons, Penrose also talks about the role of mathematics in understanding reality, doesn't he?
Oh, absolutely. He emphasizes the profound impact of mathematical concepts like complex numbers.
Right.
You know, introducing the imaginary unit I was a game changer.
It's amazing how something as abstract as the square root of -1 can have real-world applications.
Exactly. It's like discovering a new color in the spectrum. Suddenly, the equations of quantum mechanics make sense, and we can describe phenomena we couldn't before.
Math truly is the language of the universe.
Definitely. And Penrose uses that to delve into even deeper mysteries like consciousness.
Right.
He doesn't think consciousness is just computation.
Yeah, I've heard he believes consciousness might be linked to quantum processes in the brain.
Exactly. He suggests that the mind could be tapping into the fundamental fabric of reality at the quantum level.
That's fascinating. So our brains might be quantum computers of a sort?
In a way, yes. It's a controversial idea, but it opens up exciting possibilities for understanding consciousness. Maybe it's not just about neurons firing.
It's like there's an entire universe inside our heads, literally.
Haha, that's a fun way to think about it. And it all circles back to how interconnected everything is. Mass, time, consciousness, the universe.
It's humbling, really. Makes you realize how little we know.
Absolutely, but also how much there is to discover. Penrose's ideas push us to think bigger, to consider concepts beyond our current understanding.
And to question our assumptions. Maybe the universe is stranger than we can imagine.
As someone once said, the universe is not only stranger than we imagine, it is stranger than we can imagine. Penrose seems to embrace that fully.
It's exciting to think about what we might learn in the future.
Definitely. And who knows, maybe one day we'll detect those signals from previous aeons or understand the true nature of consciousness.
Or even join the cosmic conversation with other civilizations.
Now that's a thrilling thought. It makes you wonder what kind of messages are out there, just waiting for us to decipher them.
Or perhaps waiting for us to comprehend the right questions to ask.
Exactly. It's all about expanding our perspective.
Well, this has been a mind-expanding chat. I feel like we've just scratched the surface of Penrose's ideas.
Same here. There's so much depth to explore, but I guess that's the beauty of it. There's always more to learn.
Absolutely. Let's keep pondering these big questions.
Agreed. Until next time, let's keep our minds open and our curiosity alive.
Sounds like a plan.
Welcome to the Hey Gen podcast. Today we're diving into Roger Penrose's fascinating ideas about the universe. It's going to be a wild ride.
Oh, I can't wait. So what's the big idea Penrose is bringing to the table?
Well, he suggests that mass is like a cosmic clock.
Really?
Yeah, every particle with mass ticks away at its own intrinsic frequency.
Wait, so you're saying mass and time are linked through frequency?
Exactly. Using Planck's equation, E equals HF, where energy is proportional to frequency. He ties it all
Wow,
together. It's like mass sets the rhythm of the universe.
that's mind-blowing. But what happens if there's no mass?
Well, without mass, there's no ticking clock. So
Mm-hmm.
time and space become meaningless. They lose scale.
So, in a way, mass gives structure to the universe?
Exactly. It's the presence of mass that allows us to measure time and space.
Right.
Without it, everything kinda unravels.
That's both fascinating and a bit unsettling.
It is. And speaking of unsettling, Penrose also talks about a cyclic universe.
Oh,
Yeah, the idea that the Big Bang isn't a one-time event.
so the universe keeps recycling itself?
Precisely. It's like the universe expands, then transitions into a new cycle.
Interesting.
And remnants from previous cycles might be detectable today.
How would we detect those remnants?
Through gravitational waves emitted by supermassive black hole collisions in past cycles.
No way.
These waves could carry information from before our Big Bang.
That's incredible. But do we have any evidence for that?
We're still searching.
Right.
The idea is to look for patterns in the cosmic microwave background radiation.
Gotcha. So how does this tie into the Fermi paradox?
Great question. Penrose suggests advanced civilizations might communicate across cosmic epochs.
Wait, what?
Maybe they're using methods beyond our understanding.
So perhaps we're not alone. We just don't know how to listen.
Exactly. They could be manipulating space-time itself.
Hmm.
It shifts our search for extraterrestrial life entirely.
But isn't that a bit speculative?
Well, it is, but it challenges us to expand our thinking.
True.
After all, technology we've today would have seemed impossible a century ago.
Fair point. So what about his views on mathematics?
Ah, yes. Penrose marvels at complex numbers, especially the imaginary unit I. It's amazing how the square root of 1 plays a role in real-world physics.
Like in quantum mechanics, right?
Exactly.
Yeah.
These abstract concepts have profound physical implications.
It's like math is the universe's language.
Absolutely. And sometimes the most abstract math finds the most concrete applications.
Right.
It's the beauty of mathematical discovery.
Speaking of abstract, what does Penrose say about consciousness?
He delves deep into it. He thinks consciousness might be linked to quantum processes.
So, beyond just complex computations in our brains?
Exactly. He challenges the view that consciousness emerges solely from computational complexity. He suggests a fundamental connection to the quantum realm.
That's a bold claim. Do you think there's merit to it?
I think it's worth exploring. It could revolutionize our understanding of the mind.
It certainly pushes the boundaries of neuroscience and physics.
Definitely. And it opens new avenues for interdisciplinary research, combining physics, biology, and philosophy.
It's exciting to think where this could lead.
Agreed. Penrose's ideas remind us how interconnected everything is.
Exactly.
From particles to consciousness, it's all linked.
It's a lot to take in, but it's thrilling.
It is. And it shows the importance of keeping an open mind.
Yeah.
The universe is full of surprises.
So, what's your biggest takeaway from Penrose's theories?
For me, it's the idea that we're part of a much larger cosmic cycle. It puts our existence into a grand perspective.
Definitely makes you ponder our place in the universe.
Exactly. And inspires us to keep exploring and asking questions.
Right.
After all, curiosity drives discovery.
Well said. This has been an enlightening discussion.
Absolutely. Thanks for diving into this with me.
Anytime.
Can't wait for our next cosmic chat.
Me neither. Until then, keep pondering the universe.